Entropy, the direction of time. Time. What exactly is time? It's the thing that clocks tells you. Fine. Let me make it a bit more specific. Time, according to the dictionary, is the measured or measurable period during which an action, process, or condition exists or continues. The duration. I am 99.9999% sure that all of you knew what time is. And for those that didn't know, 99.9 infinity is actually 100. Anyways, next. 2. Entropy. Entropy is something that we take for granted. Some observations that we already have about it is that time flows from past to present. Like you go from a child to a slightly larger child and a even older child. That's kind of obvious. It's just how things work. A mysterious thing. By now, you probably know that reversing some things are almost completely impossible. Some examples that you may think of are uncooking something, such as if you cooked an egg on a frying pan, you wouldn't just be able to return it to its raw state. Traveling back in time is highly unlikely. Unspilling something and returning it back to the exact state before, or unbreaking something and returning it to the exact state before, are also extremely unlikely. And when I say extremely unlikely, I mean to the point where it never happens. A fun fact: the hefty arsenal of laws of physics that we possess all say the same thing. There is no distinction between past and present. Physics treats past and present as the same thing. Time in physics is slightly like space. There is no up, down, left, or right. Cool, right? Time flow. But there must be something wrong because we know that time passes and it goes forward. And we can influence things in the future, but we can't change things in the past. Like, if I wrote myself a note to go and buy groceries, I would be able to buy groceries. But if I didn't go to the grocery store yesterday, I wouldn't suddenly be able to go to the grocery store yesterday since that time has already passed. Entropy, according to the dictionary, is the lack of order or predictability, the gradual decline into disorder. This is one of the more popular ways of saying it, but it can actually be misleading. An example of this is if I have 2 cups, one full of ice and one full of water, I could ask you which one seems more disordered. Most of you would probably pick this one. But the thing is, this has less entropy and is less disordered than this one, which is circled in green. Cool. Entropy, in other words, can also be described as the measure of probability of each configuration of energy that without change in the micro or macro state. For example, temperature, pressure, and volume. Now let's talk about this thing. It's the equation for entropy. S stands for entropy. Kb stands for Boltzmann's constant, and the omega symbol stands for the number of microscopic configurations. A simplification of this is that entropy is always increasing, or energy is always spreading out. If I have a cold cup and a hot cup and I placed it together, eventually the hot cup will cool down and the cold cup will heat up, and eventually at some point they will have the same temperature. But why? This is where probability comes into play. Say we have 50 red ping pongs and 50 blue ping pongs, and we painstakingly arrange them perfectly so that all of the red ping pongs are on the left and all of the blue ping pongs are on the right. Then, for some reason, we wanted to destroy our work. We would close the box and we would shake it up, and we would probably get something that looks remotely like this. Of course, not exactly like this, because there are so many different possible configurations in which the blue and red balls could take place. Say is that if you have this box of 100 ping pong balls, 50 of which are red and 50 of which are blue, and you shake them, the red and blue will probably be mixed together. In real life, if we replace each of these ping pong balls with a few million or billions of atoms, the chance of the box returning being filled with these atoms or pieces of energy, whichever you would like, or quanta, it will probably never return to this. Now, there is a tiny chance that it will, but it's statistically so small that we never really see it in life, ever. So it basically never really happens because the chances of it happening are so small and minuscule. So in the end, when you shake it, which is, time progressing out, and it having the minuscule chances of returning to what was before, is entropy, or the force that is not allowing things to go back to their perfect original state, or the state it was before time progressed, is the thing called entropy.